For standard G1, what's nice about this standard is you actually already know how to do about half of it, because it uses a very similar graphing approach that we've done in the past. So to get a 3, the standard is I can graph square root and cube root functions by hand and find desired values using the graph and a calculator. So reaching that standard, which is what we're going to focus on today, will give you proficient. The 4, the extension, is being able to do it, finding the domain and range without necessarily having the graph in front of you. Alright, the main radical equations that we come across are the square root and cube root functions. So it is a good idea to have an idea of what their graph looks like and be able to sketch a picture of the pattern. It's easier to think of these function graphs in terms of their inverses, quadratics and cubics. So meaning like the square root function is the inverse or the opposite of a quadratic, and the cube root function is the opposite of a cubic. Remember that inverse functions have opposite graphs, or graphs that look like they have flipped over the line y equals x. Now that line y equals x is the line that goes up through the first and third quadrant. The slope is 1 over 1, y-intercept is 0, 0. So your graph is going to look like it's flipped over that line. For example, with a quadratic, y equals x squared, the rough sketch of what that graph looks like that. Its opposite function, which is the square root function, looks like this. So if we were to draw that line in, it does look like this piece of this graph flipped over that line to get our new function. Now the reason we don't have the whole quadratic or the whole parabola laying on its side is because if we had the whole U shape laying on its side, it wouldn't pass the VLT, so you wouldn't have a function anymore. So we have y equals the square root of x, and it's just half of the quadratic graph. So this is a quadratic. This is the square root. Okay, with a cubic function, now without any transformations or numbers added or anything, your normal cubic function looks like that. Has some slight curve in the middle, but that would be your normal cubic function. And then with a cube root function, it looks like that. So again, it looks like you have flipped that graph over that line y equals x to get your new function. Okay, so these are the two shapes that we're going to be focused on today, or the ones that we're going to be graphing. So steps to graphing radical functions, and we just deal with square root functions and cube root functions because they're the most common. We're going to start by labeling the transformations. Okay, so your two functions are going to look very similar. Oops. Oh, you know what? I'll do this instead. The only difference is the index. But you have your h and your k going on still here. So that h and k are going to move your graph the same way they've moved quadratics, absolute values, and the other functions that we've dealt with. So you start by labeling the transformations. Then we're going to make a small table of values. Now, for this one, we want to use values that make sense. So for the square root function, the numbers that are easy to take the square root of are 0, 1, and 4. Those are numbers that we can plug in and take the square root of, and it's easy. For cube root functions, we don't have to do anything really crazy because you can take the cube root of -1, of 0, and of +1. So those are the numbers we usually use. Okay. Plot points. Shift. Draw in the graph. domain and range. For square root functions, your domain is going to be based on your h value. Your range is going to be based off your k value. For cube root functions, since we can plug in negatives, because the cube root of -1 or any negative, like the cube root of -1 is -1, because -1 times -1 times -1 is -1. The domain and the range end up being all reals, because this graph up here that we made for the cube root function, that's going to go on forever and ever in both directions and have a slight increase until it covers every y value. Also look, really quick, with cubic functions, you increase very quickly over time, where with cube root functions, you're going to increase very slowly. Okay, that'll give us enough to start. Go ahead and flip your page. We're going to graph example 1 together. Okay, so let's start with y equals 2 times the square root of x minus 2 plus 3. Okay, first thing that we're going to do is label transformations. This 2, this h value, is going to move my graph to the right 2. This k value is going to move my graph up 3. Hopefully, we don't need to refresh your memory a lot on that since we've done these transformation things quite a bit. If you need a refresher, make sure you talk to me tomorrow and I'll go over it in class. And then we're going to make our little table of values. Now, because this is a square root function, I'm going to use 0, 1, and 4 because those are 3 easy numbers to take the square root of. I'm going to draw my brackets here. When I plug in 0, the square root of 0 is 0. So 0 times 2 is 0. When I plug in 1, the square root of 1 is 1. 1 times 2 is 2. When I plug in 4, the square root of 4 is 2. 2 times 2 is 4. I'm going to plot those 3 values. Okay. And then I'm going to take each of those points, shift them right 2 and up 3. Now, with square root functions, you have to be careful when you draw on the graph because remember, this is only half of our parabola, so it does have a stopping point. Can't go any further than that. Okay. You also need to make sure your graph stops so that the domain and the range are a little bit easier to pick up. If you look at your graph for the domain, your graph starts at the x value of 2 and goes to the right. So your domain is going to be x values greater than or equal to 2. And also notice that's the same value as your h. For your range, my graph stops at the y value of 3 and then goes up. So my range is going to be y values greater than or equal to 3. Just on time here. Okay. Let's go ahead and do another one. Y equals -3 times the square root of x plus 1 minus 2. Alright, again, we're going to label the transformations. This 1 is going to make my graph go to the left 1. This 2 is going to make my graph go down 2. Then I'm going to do my small table of values. For square root functions, you want to use 0, 1, and 4. When you plug in 0, square root of 0 is 0. 0 times -3 is -3. When you plug in 1, the square root of 1 is 1. 1 times -3 is, okay, that should have been 0. 0 times -3 is not -3. 0 times -3 is 0. Sorry about that. When you plug in 4, the square root of 4 is 2. 2 times -3 is -6. We're going to go ahead and graph those 3 points. 1, -3. And then I'm going to take each of those points, shift them left 1, and down 2. So, left 1, down 2, left 1, down 2, left 1, down 2. And we're drawing our graph. Now this one's going to look like it flipped because it did. That negative sign makes it flip, which also is going to change how we draw or figure out the domain and range. Domain, again, is where your graph stops in terms of the x axis, the x value, stops at the x value of -2 and then goes to the right. So your domain is going to be, -1. So your domain is going to be x values greater than or equal to -1. For the range, it's going to be where it stops on the y-axis. It looks like it stops at the value of -2 and then goes down below that, so it's going to be y values less than or equal to -2. Also, keep in mind that this number and this number should also match up with your h and your k up here. Okay, go ahead and flip. A couple minutes here, we can do example 3 and 4. We're going to focus here on the cube root functions. All right. Same kind of deal. We're going to label the transformations. So you're going to go to the right 3 and up 2. And with the table of values. Now when you're talking about cube root functions, the x values that are really nice to use are -1, 0, and 1. You don't want to use 0, 1, and 4 because it's not easy to take the cube root of 4 in our heads. All right, when you plug in -1, the cube root of -1 is -1. -1 times 2 is -2. When you plug in 0, cube root of 0 is 0. 0 times 2 is 0. When you plug in 1, cube root of 1 is 1. 1 times 2 is 2. We're going to go ahead and plot those 3 points. Now it looks like it's going to form a line, but this is why it's good to know what the shape of a cube root function actually looks like. I mean, if we plotted any more points than that, we would see more clearly on the graph right now what the pattern is going to be. However, if you know the shape of the function, you can do it this quick and dirty way, and then you don't have to make a bunch of points. Now, before we actually draw my curve, I have to move each one right 3 and up 2. Okay. Then when you draw on your curve, remember it kind of goes like that, keeps increasing. And then the domain and range for both is all real. So you can plug any number in and get any number out. Okay, and the last one we're going to do together here. Okay, again, you're going to start by labeling the transformations. So that 3 makes my graph go left 3. That -4 makes my graph go down 4. Then I'm going to make my small table of values. When you plug in -1, the cube root of -1 is -1. -1 times -3 is 3. When you plug in 0, you get 0. When you plug in 1, cube root of 1 is 1. 1 times -3 is -3. So you have -1, 3, 0, 0, and 1, -3. And before we draw on our curve, we have to go left 3 and down 4. We're going to draw on our curve. Now this one is going to look like it flipped a little bit, and it's got a bigger turn here. But that negative is why it flips. Like this one you can see kind of increases from left to right, and this one decreases from left to right. And then your domain and range, all reals. Now for example 5, mark that with a 4. We will revisit that when we start going over the 4-type problems for this question. But this is basically looking at a function like this and being able to tell me the domain and range without actually graphing it. Okay, that'll be where we end.